In this video, I want to have a look at how we can solve equations that involve logs. So earlier we looked at using our calculator to approximate the solution to logs when they have a base 10 or base e, but our calculator doesn't do logs when there's any other base. It only does base 10 and base e. So the issue we have is that lots of problems involve lots of different bases, not just base 10 and base e. So we have to be able to manipulate our logs to get them into those bases that we're more familiar with and that we can use our calculator with. What we want to be able to do is change the base of our logarithm. So this formula is on your reference sheet, so you'll get it in every exam. So if we've got log to the base a of x, we can rearrange that to log to the base b of x over log to the base b of a. So that b can be anything. We could change it to log of any other base, but usually to help us out, we're going to change it to base 10. So before we start applying this to examples and having a look at how it works, I want to show you why it works. So to prove that this formula is true, we're going to start off by saying let y equal log to the base a of x. So y is equal to this left-hand side of that equation. Now at the moment this is written in log notation. Let's go through and rewrite it in index notation. So that would tell us that a to the power of y is equal to x. Now if we go through and take the log of both sides, we're going to write log to the base b, and b can be any number we want, of that a to the power of y will be equal to log to the base b of x. And the reason that's true is because if a to the power of y is equal to x, then if we take the log of both of those things, we're going to get the same answer. So they have to be equal. So now that we've got that, we want this y on its own. So we want to find something that's equivalent to this y. We know from our log laws that if we've got a power here, we can bring it down out the front. So we're going to have y times log to the base b of a equals log to the base b of x. And to get that y on its own, we're going to divide both sides by that log to the base b of a. So y equals log to the base b of x over log to the base b of a. So this is our formula since y was equal to log to the base ax and y is also equal to this side. So those two things are equivalent. So let's have a look at how that works in a couple of examples. So our first example asks us to solve correct two decimal places, log to the base 3 of 7. Now we can't put that straight in our calculator, so what we're going to do is we're going to change the base so that our logs have a base of 10. So to rewrite this one, we're going to have log to the base 10 of the x, so that whole number which was 7 in this one, over log to the base 10 of our base in our original, which was 3. And if we put that in our calculator to two decimal places, we'll end up with 1.77. Our second example says 4 to the power of x equals 0.15. So to solve this, first we're going to rewrite it in log form. So we're going to have log to the base 4 of 0.15 is equal to x. So to figure out what this is, now we're going to use our change of base rule and change it to have a base of 10. So we're going to have log to the base 10 of 0.15 over log to the base 10 of 4. And we can put that in our calculators and it'll give us an approximation to two decimal places of minus 1.37. Now it's always a good idea when you're doing these to double check that that answer works. So we're going to put this minus 1.37 up in here and we should get an answer that's about 0.15. Now because we rounded this answer, it won't give you the exact number, but as long as you're getting pretty close to it. You can do the same thing over here. You could write into your calculator 3 to the power of 1.77 and hit equals, and you should get an answer that's pretty close to 7. So always a good idea to check your answers. Alright, so that's having a look at solving equations involving logs by changing the base.